Uranium is a radioactive metallic element used primarily as fuel in nuclear power plants and historically in weapons. It occurs naturally in low concentrations in rocks, soil, and water. Uranium ores, however, are minerals that contain enough uranium to be mined economically. Major uranium-bearing minerals include uraninite or pitchblende, which is the most important, carnotite, a secondary uranium-vanadium mineral, Brannerite, which contains calcium, cerium, iron, titanium, and uranium, Autunite, a calcium-uranium phosphate, and Coffinite, which is a uranium-bearing silicate mineral. Uranium deposits form in specific geological environments through several processes. The main types are: number one, unconformity-related deposits, in which uranium precipitates at the interface between older basement rocks, often metamorphic, and overlying younger sedimentary rocks, typically sandstones overlying basement rocks. A notable example of this type of deposit is Athabasca Basin in Canada, which contains high-grade uranium deposits. Number two, sandstone-hosted or roll-front deposits, which form when groundwater leaches uranium from source rocks and deposits it when oxidizing fluids meet reducing conditions in porous sandstones. These deposits are commonly found in fluvial, deltaic, or lacustrine sandstones, areas with permeable sandstones and reducing agents such as organic matter and sulfates are particularly good targets for exploration in this context. Number three, vein or hydrothermal deposits. In this type, uranium-rich fluids move along fractious faults and precipitate uranium minerals in veins. Typical host rocks in this case are granites and metamorphic rocks. Examples of this geologic setting include the Erzgebirge in Germany and the Rosing in Russia, both of which are well-known uranium deposits. Number four, volcanic-associated deposits, in which uranium concentrates in volcanic rocks like rhyolites and ignimbrites, sometimes associated with copper or molybdenum mineralization. Number five, metasomatic or skarn deposits, which are rare and are formed by uranium-bearing fluids reacting with carbonate rocks near intrusive bodies. Number six, superficial deposits, and in this case, uranium concentrates in calcrete, sandstone, or conglomerate at or near the surface under arid conditions. Noteworthy examples of this type of deposit are Lake From in Australia and the Namibia calcrete deposit. Environmental settings favorable for uranium concentration are arid or semi-arid climates, which promote the formation of calcrete-type superficial uranium, sedimentary basins, especially those with permeable sandstones and organic-rich layers, areas with granitic or volcanic basement rocks from which uranium is leached into the overlying sediments. In addition to structural traps such as faults, fractures or unconformities that allow uranium-bearing fluids to accumulate and precipitate. When exploring for uranium, geologists look for the following. Number one, geology and rock type. For example, sandstone formations overlying metamorphic or igneous basement. For unconformity or roll-front deposits, granite terranes with hydrothermal activity, and superficial calcrete or alluvial deposits in deserts. Number two, geochemical indicators such as elevated uranium in soil, stream sediments, or vegetation, the presence of vanadium, molybdenum, or rare earth elements, which are often associated with uranium, and redox boundaries or organic rich horizons. Number three, geophysical methods, which include radiometric investigations through detecting gamma radiation from uranium decay using airborne surveys, for instance, resistivity and induced polarization to identify porous and conductive sandstone zones.